Okay, dear members of Dissertation Council. Okay, dear members of Dissertation Council, dear colleagues, let's begin our meeting. So according to order number 1.1-02/759K of SD University dated July 4th, 2025, the permanent composition of the Dissertation Council for the defense of dissertations for the degree of Doctor of Philosophy PhD in the field of 8D06102 computer science and the specialty 6D07040 computer systems and software at SD University has been approved in the number of 4 members, which are the chairman Bogdan Andrei Vladimirovich, Vitaly Levashenko, foreign scholar from Jelina, Slovakia, Al-Haditi Mohamed Al-Fathil, the assistant professor from SD University, and Dana Otibaeva, scientific secretary of Dissertation Council, also from SD University. And also at the meeting of the Dissertation Council for the defense of dissertations for the degree of Doctor of Philosophy PhD in specialty 6D07040 computer systems and software regarding the review and acceptance of Askhat Aitimov's PhD defense, the permanent members of the Council in accordance with the requirements of Regulations Dissertation Council of SD University appointed 3 temporary members of the Dissertation Council, which are Randos Dosbaev, Associate Professor from Radosbekov Institute of Mechanics and Engineering, Uzhalga Seidalieva, PhD Leading Researcher of Satpayev University, and Aygerim Yerembetov, PhD Associate Professor from Engineering and Information Technology School in Eurasian Technological University, Almaty. So currently we have, I believe, can you show the list, please?
Okay.
The list of present. The right side, yeah.
This one is.
So we have 3 members of permanent people, plus 1, 2 already, and 1 is on the way. So we have 6, 5, 6. So from 7 people, we already have 5. I believe it will be 6 in the end. From the committee members, then the quorum is present. We can begin. So the quorum for holding the council meeting is met. So we have a necessary number of participants, which is more than 2/3 of the total composition. Among them, considering the nature of the dissertation under review, we have 3 people or more. And also we have 2 official reviewers, which should be present online. It's proposed to begin the work of the Dissertation Council. Are there any objections? Can we begin? Yeah, we're in favor. Thanks. There are no objections. We'll begin the work of the Dissertation Council meeting. The agenda includes the defense of the dissertation of Askhat Aitimov on the topic of analysis and development of algorithms and methods of object recognition with the specialty 6D07040 computer systems and software. The dissertation was prepared at the SD University. The defense will be held in English. The defense is being conducted for the first time. The dissertation is presented in the form of dissertation work. The official reviewers will be Smailov Nurjigit, PhD in specialty 6D07190 Radio Engineering, Electronics and Telecommunications, who is Associate Professor in the Radosbek Institute of Mechanics and Engineering. And also Dana Tolukozhaeva, PhD in specialty of 8D06201 Radio Engineering, Electronics and Telecommunications from Al-Farabi National University. Also, we have, they're present online, I believe. Yeah, okay. And scientific consultants for the candidate, Saltanata Mirgalieva, Doctor of Physics and Mathematical Science, Professor, Institute of Information and Computational Technologies, Committee of Science, Ministry of Science and Higher Education of Republic of Kazakhstan. And also Yuri Krak, Doctor of Physics and Mathematical Sciences, Head of the Department of Theoretical Cybernetics, Taras Shevchenko National University of Kyiv, Ukraine. Are there any questions regarding the agenda? No questions? Okay, we can proceed. I request the approval of the agenda. All in favor? Yep. Who is against? No one. Then we approve the agenda. The speech is given to the academic secretary of the council meeting, Dana Otibaeva, to review the personal documents of the candidate Askhat Aitimov and their compliance with established requirements. Please, Dana.
Thank you. Good afternoon, dear colleagues. So the applicant submitted the following documents: application from him, reviews from scientific supervisors, and dissertation thesis, positive conclusion from the department where he studied also all notarized copies of higher education of the candidate and the list of scientific publications. All documents, other which documents submitted by the candidate are complete. We can continue.
Okay, thank you. Any questions to the secretary regarding the materials and documents? Okay, if no questions, we continue. Then the floor is given to the candidate for the presentation of the main points of the dissertation. Please, Askhat Aitimov, you can go on. You have 20 minutes for the presentation.
Okay. Okay. Hello, everybody. Thank you for attending to my defense. So my name is Aishim Askhat. My topic is analysis and development of algorithm and the method for object recognition. My first supervisor was Amir Ali Khan, but unfortunately he left us last week. So my current professor is Amir Ali Sultanat, and external supervisor is Professor Yuri Krak in National University of Ukraine. So, okay, introduction. As we know, object recognition is the process of identifying images and classifying and identifying images. It uses algorithms and so on, and it covers many categories. But in this research, I focused on hand gesture recognition and the face recognition. So here next. Relevance of hand gesture recognition and the face recognition. So according to the study of Rashid et al., the main popular spheres in relevance of face recognition is healthcare, security and education, surveillance and law enforcement. In hand gesture recognition, it's a human computer interaction, gaming like a PS, Kinect and so on, and robotics. So there is multiple challenges in hand gesture and the face recognition according to the Bansal. So here's just, for example, variability. Objects can look different due to the lighting, angles, and so on. Occlusion problems. Object may come partially hidden by other objects. And here also one of the point which I focused in my thesis, it's a limited data. So problem statement. Limited training data significantly restricts the development of accurate and reliable object recognition system, as deep learning models typically requires large and diverse dataset to perform well. Research question: how do limited datasets impact the performance of face and hand gesture recognition, and what lightweight approach can be developed to maintain high accuracy and efficiency under the limited dataset? Research aim is to develop an algorithm and a method for face and hand gesture recognition efficiently capable of achieving high accuracy under the limited dataset. Research objective, I have two. First is to employ limited dataset frequently used in researchers. Second one is to develop a lightweight and efficient recognition approach for face and hand gesture recognition for identification that ensures high accuracy and computational efficient in data constrained environments. Scientific novelty, the scientific novelty of this research lies in development of lightweight object recognition algorithm and a method that integrates PCA, a modified triple similarity loss, and a projection-based classification stage to ensure accuracy performance under limited dataset condition for the face and also for hand gesture recognition. So main references which I use it in my thesis. So I already explained in previous slide, first two. So for example, challenges in collecting large data dataset by Bugaji and Mittal et al. Challenge in collecting large dataset. In my thesis, I use a traditional and modern deep learning model. So also I here write the main references. So short in total, I have 156 references, more than 67% it was published last 7 years. So more than 65% are researchers where the experiment exists. So let's come to the objectives. Objective 1, when dataset is considered limited. So according to the studies, it's widely accepted that dataset is limited when it's lack enough examples or quality to reliable train deep learning models. And in some case, it also depends on task complexity. So this is the growth of limited dataset research in unlimited datasets. So here, as in last 5 years statistics, as you see, in 2020 there was less than 300 works, but now in last year the number of research in limited dataset is grows to more than 2,000. So additional information about collecting dataset, especially in face detection. Why? Sometimes it's restricted by low security and surveillance and the privacy and ethical consideration. So objective 1, I datasets which I use it in my experiments. It's first of all, it's a handwritten dataset. It's very small. It just have 500 static image as shown in figure. It has 10 classes. It's alphabet American letters A, B, C, D, and so on. Every pose, every letter has 50 images in it. So it's open source. Second one, it's an oral dataset. It also has 400 images, just 40 individuals, 40 persons. Each has 10 images at different conditions. Size 112 by 92. All images are grayscale and also open source. You can see in image. So, objective 2, development of lightweight and effective recognition approach for face and hand gesture recognition. I divide this part by two. First one is traditional classical algorithms. It's a KNN, support vector machine, random forest, and so on. And second one is trending deep learning methods. For example, convolutional neural networks, transfer learning, data augmentation, GAN, federating learning, and few-shot learnings. This is the most popular algorithms according to the research. Okay, combination of component analysis and similar triplet loss function and the projection-based classification, shortly called PCA-TP. It's my proposed method. So what these do? I use PCA to reduce dimension. PCA reduces dimension by saving important information. So after it comes to the similar triplet loss. The main idea of similar triplet loss is grouping similar classes. So, for example, as shown in the figure, you can see first of all it takes one picture, for example, my Askhat picture, and take another my picture, positive one, so 2 Askhats, and it calculates distance and try to make closer, and take negative one, for example, Bauran, and try make it far apart. So last is projection-based classification. We use to evaluate and testing. It uses cosine similarity. Experiments on hand dataset. Okay, so in first my experiment, I use handwritten dataset, mentioned 6 classical algorithms in 6 different image size, in 3 different image representing RGB, histogram, and grayscale. In this experiment, I take 80% of dataset as training, other to test. So result is KNN, and random forest was showed the best performance in grayscale image representation discussion. Histogram method not effective in object recognition. So second, also in second experiment, I take KNN and random forest as show the best result, and also take experiment new modified SRC algorithm. It's also not popular, but use it in hand gesture recognition. So also same 6 different image size, but just one image representation grayscale. Here I decrease training to 60%. other goes to test. So KNN shows stable in all sizes, 95, but MSRC shows best performance, 97 and 5%. But unfortunately, error shows less. Okay, let's come to the experiment on hand dataset with proposed algorithm PCATP. Here also we use KNN, also MSRC, and my proposed method. So here we use hand data reader, and we give just 20% to train, and other goes to test. So we do two different tests without preprocessing and with preprocessing. Here, dataset processing, I take original image and converted it to the grayscale using threshold 60, converted to black and white image and crop it and rescale to 30 and 30, flatten it into one-dimensional vector and use PCA as dimensional reduction. So, as you see from the table, the PCATP proposed algorithm or proposed method shows best in both cases, shows best accuracy. So in experiment with preprocessing step, it achieves 95%. In without preprocessing, it achieves 77 more than 77%. So here, this second diagram shows accuracy of every letter. For example, A, B, C, D. Let's take letter B. For example, in experiment without preprocessing, it gains just achieves 75%, but when we use preprocessing step, it achieves 100%. So next, I used face dataset. So here, also, the first experiment was take KNN and just PCA without triplet loss and the proposed algorithm PCA-TP. The main idea was to how triplet loss function affects the results. 4 different sizes of training and test, maximum give 80% for training and in last 20% for test, training. So result, PCA-TP shows best performance in all experiments. In 20% training, it achieves more than 84% accuracy, and in 80% training, it achieves more than 98%. So here, if we compare PCA and PCA proposed PCA-TP, the triplet loss function increases 3% in 20% of training. So from this I stopped experimenting with classical algorithms and started with deep learning algorithms. So here 4 different CNN models. I generate 4 different CNN models, same experimental setup, but here just 2 different sizes. As a result, in 80% training, CNN achieves high results, more than 95%. It means that when we give more data to CNN, it shows great perfect accuracy. But when it comes to the 20% training proposed methods, there is a difference. For example, in my proposed algorithm, in 20%, I achieve more than 84%, and CNN achieved less than 72. Okay, so there is a difference when we work with small data set, limited data set. Next experiment, related work, Genly and Color is proposed a CNN-based face recognition model. Also, they use oral face dataset, and they use 30% of dataset for training and use preprocessing steps. So they reported that they achieved 93, almost 94% using just 30% of training data. Here also we do same. Also preprocessing, I just take image and resize it same as the related work, 36 to 36, using Gaussian smoothing with coefficient 0.015, flatten it, and next, this is preprocessing. Next, PCA text input and using component 45 decrease the matrix and with saving most important information. So then it comes to the triplet loss. It takes and works. It calculates answer positive, negative one, and changed it. And using using my projection based, I evaluate the results. So results here, the results as you see. First one is my current experiment. Second one is the experiment, early experiment, and the third one is a related work experiment. So here, as you see, in 20%, just 20%, we achieved 91 and 25 accuracy. It's comparing with it with my early experiment. There is a 7% difference. And in 30%, we achieved 95%. It's with comparing with the related work, it's higher than to 1%. So next come to the modified triplet simulation embeddings. So here I modified triplet lost. Okay, so just use just three different, make three modification. First, use it cosine simulation instead of Euclidean distance. It was first of all. Second, I normalized it and using adaptive margin instead of fixed margin. So here, comparison standard, we see modified triplet loss. So here in standard, it uses Euclidean distance. In modified, it uses cosine similarity. Embeddings can vary in scale. Embedding are normalized. Learns distance in magnitude. Learns direction relationship between samples. Fixed margin for all triplet loss. Adaptive margin depending on difficulty. Sets all triplets equality. Adjust separation if there is a hard, stronger margin. If there is an easy, softer margin. So last experiment. We repeat previous experiment, but just with 20 and 30% because of limited data set. So here, it's my current work and his previous work. So here, in 30%, it was 95% and increased to almost 97%. And in 20% of training, it achieves also increases by approximately by 1% accuracy. So let's talk about training deep learning models on oral dataset. During my PhD, I have analyzed more than 100 research papers where researchers use oral dataset, and here I put just high experiments with high accuracy. So here, for example, data augmentation, first after use data augmentation with transfer learning and using training setup with 80, achieves 95%. Comparing with our proposed method, we have 100 in this case. So here, the two works shows highest result comparing with me. So here, one of these data augmentation, flipping, rotating, cropping, plus CNN, plus PCA, plus few shot, they use 30% training and achieves 98. Comparing with, I have 20, almost 97. The second one is the data augmentation, flipping, rotation, scaling, plus CNN, plus SVM, using 50% of, I would say, training. So it achieves almost 100. In this case, I have 96. So I take these papers and analyze it. So limitation reported by authors in data augmentation basis. Here all the highest results achieved by data augmentation. Okay, so here authors reported that these overfitting risks. The author mentions that deep learning models can overfit on repetitive and analytic augmented samples, especially when synthetic data dominates the training set. Second problem, increased computational load The authors in experiment generated between 6,800 and 100,000 augmented images, which dramatically increase storage, training time, and the GPU requirements. And third one, it's a generalization risk. The use of artificial data might not generalize well to natural variation in real-world test data, especially if the augmented types rotation don't match real usage of condition. So here, comparison of proposed PCATP with data augmented based deep learning. So first, data requirements. In PCATP, it's very low. With just 2 images per class, you can achieve more than 19% in oral dataset. In data augmentation, they require large augmented dataset, more than 500 images to do this, to achieve this result. In computation, we have lightweight, fast training. It's just there's no layers, there's no deep learning. It's all mathematical formula, used mathematical. But in data augmentation, this high GPU usage, long training times, and generally strong under too low data condition in data augmentation can overfit the systematic. And simple iterative model, data augmentation has complex, and so on. So during the process of research, the aim objectives and following results were obtained, employed limited data frequently used in research endeavors, and developed a lightweight and efficient recognition approach for face and hand gesture recognition under the limited dataset. So, publications and authors' contributions. During PhD, I have published 9 researches in all, not in 7 of them. My responsibility was to write coding, make experiments, and so on. And the last 2, it's my master students. I just in these papers, I just guide them, explain methodologies and implementation, check their papers. So thank you for the attention.
Thank you very much. The presentation is concluded. So are there any questions? Please, can you show the screen with the images? Maybe there are some people from online presence. No, stop the presentation for now. Yeah, okay. If you have questions, please, you can raise the hand or just open the mic and speak up. Anyone? Yeah, please, Professor Alonso, you can go on first.
Okay, thank you, everyone. Thank you. I just want to have ask some just short questions. Actually, I had some internet issues, so some of the part I just missed it. But I think I have read your your dissertation, and I had some background about it. So I just want to know, why did you use grayscale image? I mean, why is not colored? Is there any difference?
Yes. Can I switch to my?
Yeah, please. Can you use shared screen?
Okay. So here, why I use grayscale image with not original one? Because in RGB, in original one, its matrix is 3 times bigger from comparing with grayscale. So it means that you need to work 3 times. Algorithm will work 3 times more. But the results are same. I can show you here in detail. So here, it's my first experiment. I just showed it in table. So here, as you see, this is the RGB. It's a original image, and grayscale. It's a just grayscale image. So here, all the results are same, mostly same. So you need to. It's easier. It's faster to use grayscale.
Okay, so it's just for time frame, right?
Yes, just faster. Yes.
And okay, So you're aiming to develop efficient algorithm that's for object recognition under limited data conditions.
Yes.
Can you just set out what is that conditions that you have considered and why you consider is important in your research?
Why it's limited is important. Working is limited.
No, I said you are working under limited data sets, right?
Yes.
So what is this condition that it's make it limited? What that conditions? Why you are considering these conditions are important in your research?
So here I explained that when is data set considered limited. So here these three main points. It says that if you have low count, quality over the quantity, and task complexity, for example, one after uses reported in his research that dataset with fewer than 200, between 200 and 500 image per class, it says limited. Okay, some authors say that dataset with more than 100 images with per class, okay, it's also how to say considered as limited because of task complexity. So in some cases it's hard to take hard to collect data. For example, in phase the most of the there is a how to say law which restricts dataset. In some case it's you need to more money, you need to more support, financial support to collect unaltered datasets. Okay, so in this case my work is focused in this case.
Okay. Okay. Can you just go to slide 30?
30.
Yeah. So here you put, I mean, is this your limitation or other studies limitation?
No.
Because
This is,
actually, we should expect that here you are presenting your limitation, and I think we prefer to see the limitation of your study than others. So
okay.
it's not your limitation, right?
Yes, it's not my limitation. Here I
And
write this one. Okay, continue please.
okay.
Should I answer? Okay.
Yeah, proceed.
Here I showed most highest achieved accuracy works. It's not my works, and say and analyze them. Do you see with the red one papers with that one? They achieved how to say they achieved performance, highest performance than my work. But when I analyze it, these are three main points. Okay, the authors mentioned in their works these limitations.
So it's kind of like the okay, like it should be in related work, right? It's kind of you're analyzing their work, even they are achieving highest accuracy, but they still suffer from some limitations, right?
Yes, the main here I want to explain that with lightweight algorithms like PCA-TPA, okay, without not using data augmentations, without creating or make it how to computational load, we can achieve the same highest accuracy. I just want to show it in here.
Okay. So is there any limitation for your study?
Yes, as you see, here's a more. In fact, I have done all this experience in my own. So, but when I use our PCATP with transfer learning, with data augmentations, unfortunately, it shows low accuracy. So I didn't put here. It was lower than 80%. So it's I need to work in this in future. So I need to
Okay.
how to upgrade my accuracy.
I see. Okay, thank you so much.
Thank you
Okay,
for the
thank you,
question.
Professor. And we can switch back to screen. Do we have any others who would like to ask questions? Okay. Yeah, Ulragas, Sedaliva, please.
Hi, good afternoon.
afternoon.
Thank you for the presentation, but I have several questions which I'm very interested. The first one is about research novelty. So you say that your novelty is just mixing several methods, but what is the difference this PCA triplet loss pipelines compared to other classic this PCA triplet loss? What's your original contribution to classic algorithms? Can you just list your contributions?
Here, during my PhD, I tested, I experienced all these mentioned algorithms, classic algorithms, but this one PCA with the combination with triplet loss shows, how to say, highest accuracy. But when I use PCA with other algorithms or triplet loss with other algorithms, it doesn't show the highest result.
But you should have shown all these results in your presentation, because we are not sure how did you do, because every time you say it's at a limited data set and it's lightweight, but no runtime, no computation experiment proof. Can you show us a lightweight solution? Can you prove us as your, which is your runtime, what is your runtime, computation time, and I couldn't see it in your presentation.
Okay, I have different types of statistics in my with diagram and so on, but I didn't use how to calculate runtime because when I researching this, working with other experiments, I have said that I have used it. I have read more than 100 experiments in oral dataset, but when it coming to the limited dataset, most authors, more researchers just tries to achieve the highest accuracy, but so I also doesn't compare with the runtime, so I just work with accuracy.
I think that we can comment on how fast did it train the models. Is it fast or slow? Did it take time to run this?
No, it doesn't take a lot much of time, but when I use data augmentation method, in my case, with my computer is a gaming computer, so it has good parameters, but when I started generating new images, so it takes me 30 minutes, and the computer just
what about your work? Did it run in 30 minutes?
No, it's
No?
just
Immediately.
Immediately,
Okay.
because these are just 2 images, 3 images.
Okay, next question. How do you ensure that your reported high accuracy, like 95%, is not simply overfitting to small data sets? Where is your overfitting or underfitting issues? Did you have during the experiment? You didn't mention this in your presentation.
As I understand, you're asking me if in my this is overfitting, yes? I didn't use.
Was there any issues?
No, there is no issues because it's really small. Maximum I use it for training 8 images. So here it doesn't show any overfitting. Overfitting always, not always, in most cases, it how to say, appears when you use large data set with augmented data set in transform data set, because they model learns from training, and in real world it takes, how to say, shows bad results. It's how to say, it's a most problem when you're using deep learning models. So in my case, there is no problem issues with overfitting.
What about your method, principal components? How did you choose the number of principal components? Is there any optimal rule to choose?
I tried, in most cases, I tried component numbers 45, 60, 80 because
show me in your presentation, please, not just words. Just show me real numbers.
in last experiment, I use 45 components of PCA. Here.
Where is it?
Here. So here, image come, it's n, here n is the number of samples. For example, 2 samples, 3 samples, 100 samples, so on. And second one, it's the size of image, okay? 36 multiplied by 36, okay? So when we use PCA with component 45, it decreases n 45, it 20 times, how to say, it compares 20 times, approximately.
Why 45? Why 45? Why not 40?
Here I just put most, how to say, most best results. So in my experiments, I usually
What is the rule? What is the rule?
Rule?
What is the rule of choosing PCA components, number of PCA components?
It depends on task. Sometimes it shows better result when you use 6 components, 60 components. Sometimes it takes best in 20, but it depends on, how to say,
so it's just a game. You can play with different numbers, no rules.
These are recommended rules. So I use it 4 or 5 types of K according to the papers. But there is no rule how you need to. There is no rule which says you need to do 45 or 60. It depends on depends on experiments. So when when researchers use PCA, they always shows experiment how say when PCA K component is 45, I get these results. When PCA is 60, I get these results. But there is no how to say the real answer. Why did you choose?
No,
I don't find this.
Okay. What about the data sets? You didn't include any your custom own data sets, only public data sets, yeah? Why you didn't choose your own data set? For example, all these data sets are with clear background. What about in real world scenario, it might have cluttered backgrounds. Did you consider this case?
When I doing this one, I focused on a limited data set. For example, if I use my own generated data set, I couldn't compare my work with others. I couldn't get idea how I can improve my results. So this case, how to say, for this because of this, I choose one data set and try to get higher results. Yes, in future, I'm going with my professor. We in the project. So in this project, we're going to use this algorithm method in other spheres, in real data spheres, but I really didn't check it.
In your comparison table, you compared your work with deep learning, like trending research works, but you didn't mention what other researchers, how many data sets they use it. Maybe they use it and other data sets, number of data sets, because you said you use only 2 images, for example, 4 classes. I think very low data set you used, and I think you can't compare with your work with other works. Maybe they use it big data, so huge data. How can you compare which components are the same with your, which I can see in your, you just showed your results, the same results, but what about the pre-processing steps? What about the data set number? Can you explain this difference between you and between your work and other researchers here in this table? Not just results.
Okay. In all these cases, I use the same preprocessing, same preprocessing image size. Everything was same, and then I do the experiments. I didn't do the, for example, this experiments do without preprocessing, but I do this with preprocessing, and I have highest results. No, as you see, as I explained in this, here was one experiment. Here, Lightwork, for example, generally and colleagues, preprocessing size, they use images sized to 36 to 36, use smoothing Gaussian or similar, and explaining they use CNN technique to stabilize this is their method. So same, I do the size 36, smoothing same. I have same preprocessing. So after it, I use my PCATP, then compare the results. Here, all experiments done with this work, with this logic.
What about the weakness and limitations? You just showed limitations of other works, other methods, but about your method, you didn't show any detailed the list of limitations. Can you just prove not with just own words, with real numbers, real facts, limitations?
I didn't put it to the thesis or put it in presentation, but I just can say that there's limitations. I have limitations. For example, it best works in oral and hand dataset, but I really didn't check in other datasets. This is my first limitation. Second one, I didn't check it in real cases. Okay, so I tried to focus it on one dataset, and here I tried to make get higher results, to focus it on one dataset, because these datasets are more popular, because these datasets have a lot of experiments. So I just try to comparing with them, try to develop lightweight, not deep learning without data augmentation, transfer learning methods, with just simple simple method which have highest results or similar to their results.
So it's a PhD defense, and it would be great if you should have listed all these numbers with real numbers, with real facts in the future. Okay, I don't have any questions.
Okay, thank you very much for your.
Thank you. Can you? Can you show me the screen, please?
Okay.
Do you have any other questions, Rogas? If you don't have questions, please remove the hand. Maybe Dana. Yeah. Okay, Dana, if you have any questions.
Thank you for your turn. So I would like to ask about your chosen objective. So initially on your topic, you have chosen only object detection. You took it generally. So you are mentioning on experimental part, specifically hand recognition and face recognition. But we know nowadays a lot of objects are famous with their detection tasks. Yes. So why did you choose these two objects?
These two spheres, yes?
Yeah.
Okay. When I start my PhD, my supervisor won the grant in ministry. So the topic was about to create a robot which should understand gesture recognition and detect face. So here I started this one because of this.
So you mean you have chosen two object types and you tried to solve whole object detection tasks, or I didn't satisfied with the answer?
Initially, we planned that I will use this in many spheres. Okay, but I started I explained why I started from hand and face, but in future we planned to use it in other spheres, but I didn't practice it yet. But in
So,
future,
okay,
it will be.
next question. So, right now we understood you have chosen two directions, object and hand and face. So how many classes or categories in your class, if I understood it's multi-class detection, yeah? In face recognition and hand, how many categories or classes?
In hand, there is 10 classes. In oral dataset, face dataset, there is 40 classes.
Why did you choose only ready data, open data set? Why you didn't try to use, for example, national our face data set? Did you try or did you have any intention to include your own data set? Because as I understood, 6 years, yes, about
Yes.
to your research. So why didn't you include your own data set?
The main reason, as I explained it, this is I want to compare my work with other results. In research, I read that oral dataset is most used dataset in face recognition. So I take this, select this one. But if I, generate my own dataset, it will just my results, and I cannot compare it with other works. I will not have idea how to improve it. Okay, so as I have made two pre-defense, because first, unfortunately, in first presentation defense pre-defense, my old supervisor was conducted, but after he left us, I must do second pre-defense. Here, I want to say that in first pre-defense, I do some experiments, but when it comes to the second one, I add 2 experiments more. I want to say that every time I am implementing, every time I am improving my results. So if I use my own dataset, they will not work where I can compare it.
Okay, I got it, your opinion. So next question, how did you choose your proposed algorithms? So how, for example, we can understand that machine learning is a big sphere. It has deep learning and traditional machine learning algorithms and the hybrid ones. Yep.
Yes.
Nowadays, a lot of scholars are using. Why did you choose your proposed algorithms? How did you stop it to choose that one? Because there are two ways to choose, two methods, I mean, empirical and on the base of mathematical model, or on the third one, on the base of famous publications or related studies. Yep. So in your case, how did you choose? How did you stop on these algorithms? Or how did you start? How many times, how many iterations were?
It takes CS, and not CS, or yes, it takes CS before I find these methods, triplet similarity loss, and this combination proposed algorithm. How I get this? So I tried a lot of experiments with other, other algorithms. But when I try to change something or combine with other methods, it wasn't great. So when after 3 years, now in my third year of PhD, I read the paper about triplet loss similarity. It's machine learning methods to upgrade the upgrade the result. So, but interesting case, all the papers related with this method are used after CNN, after deep learning methods. So I just think that what if I use this not deep learning, PCA? So I combine them, and it shows great results. So I search like works same like this and didn't find. So I consult with my advisors, consult with SDPG workers. So they say it will be your novelty. So I focused it, and year by year I am trying to improve it.
Okay, could we move to the presentation to your proposed algorithm hyperparameters, please? Архитектураның құрылымы.
Evet. Just a minute. So it's not hyper, just this idea how I combine them, and in last experiment I use these parameters. Here just K45 and the margin just 0.55.
So what's your novelty? Could you mention one more time, please?
First novelty as method, it's a combination of PCA and triplet loss algorithms with project based classification, these three algorithms, because nobody till for me doesn't combine them.
How many papers, publications have you considered to say this conclusion that nobody?
I research all.
And which databases?
How to say? I search all papers which mention it about triplet loss, simulated triplet loss, find every papers and read, but all of the researchers use it after CNN, after deep learning. So I just didn't find works which is not, but I searched many times. I don't know the current number of, but I think in three datasets for Scopes, EA, and Springer, I searched all of them in these datasets, but didn't find.
So how did you choose then to combine by chance or how? If no similar works or scholars did.
I think it was I don't think it was Spartanos fault, because before it I already work with algorithms, classical algorithms. So the idea come, what if I combine this one? So I didn't read that PCA will be great if you use with this one. So I just.
Did you mention about this literature review part on your dissertation thesis? Like, how did you cover it, all publications in this field? So did you cover on your literature review?
I didn't add all, but I added the first paper and the main paper where it is published triplet loss and explain it, and also I added papers where I get idea to make modified. I have two notes here. What this one? First one, it's a method combination of the three algorithms and the new algorithm, which I just modified triplet loss. Okay, but the idea I take from another papers. Some authors do adaptive margin, some authors do cosine, but they don't do this like in this sequence with this parameter.
Could we see
Ні, не
your?
можу. У мене йде захист. Я би набрав пізніше.
Okay.
Гиперпараметрлеріңізді анықтап біз көре аламыз, презентацияңызда бар ма қосқан кезде?
Мен қоспадым.
Диссертацияда бар ма?
Бар.
Okay, thank you. Okay, Professor, thank you. So I have just a maybe, I don't know, general question. This nowadays we have like AI solutions, we have kind of deep learning, we have machine learning solutions. You mentioned that most of the triplet loss algorithms are applied after the CNN convolutional networks and the deep learning algorithms. So I wonder, could you also share your opinions why it's important to work on this kind of limited data sets and how it's going to be applied, how can be applied in real time.
Okay, nowadays, yes, I understand your question. Yes, there is a cases when you cannot collect annotated data sets, and send a data set which will be enough to train train good model. In
Can you give
cases,
some examples, please? Yeah.
for example, when I read this, the medical one,
Mhm.
for example, tumor detection.
Mhm.
Okay, here they say that tumor detection, this is not annotated data set because nobody can say just it has tumor or not. Okay, it need to the expert say that this is tumor, this have tumor, this is no tumor. Okay, so this one first, it's time costing. Second one, there is a lot of laws which restricted data sharing. For example, in face, in also medicine, in when you're working with children, you cannot use any how to say, you cannot just take picture or something else to do your research. You need to how to say take you need to ask from university, from parents, and so on. In this case of in such cases, it's hard.
Okay. Thank you. Please, can you stop the share?
Linda
Yeah, okay. Jandos Dospaev, yeah. If you have any questions, please.
Thank you so much. So could you describe your data set? First question. And second question, could you explain the reason of choosing PSA analysis?
Okay, thank
Can
you
you
your
hear me?
question. Yes,
Yeah.
yes. Okay. First,
Share the screen.
okay. First one, data set is. Wait. So this is oral data set. This is hand-read data set. It's open source. It's not my data sets. So why I choose these data sets? Because it says that in one research, I also add it on references in thesis. This is a work that says the most used data sets in phase on in hand, and they mention these data sets. So because of this, I choose this to take more experience, to take to gain a lot of experiments and ideas how to say improve. And second questions was about I forgot PCA. As I understand, as I explained it, so here before I meet with the how to say similar triplet loss function, I have a lot of experiments with how to say KNN, with PCA, and so on. So here before finding, I already have experience in this sphere. So after I meet this with the triplet loss similarity, I just get idea what if I will combine them. I don't just combine just PCA. I also combine KNN and so on. But the highest result shows PCA. That's why I use it.
Okay.
So okay.
One more question else. Then we have also independent component analysis, yeah, as you know. So what is the pros of using principal component analysis in your case?
I use for dimension reduction. It means it means that it takes how to say it saves, it reduces dimension matrix size, but saving the important important information. So it makes it smaller and just take important information. So because of it, PCA mostly used one of the mostly used algorithms. It also affects to the how to say speed of algorithm. Also, it's also affected to the accuracy.
Okay. Can you close the sharing, please? Okay, I think we had enough questions. And by the way, thank you for connecting, Professor Randos. I think that you had some technical issues, but in the end you connected. Thank you very much. So we can move to the next stage. We had a lot of questions. So we should hear some speech from domestic scientific advisor, Professor Saltanat Amirgalieva.
Good afternoon, dear colleagues. Қайырлы күн, құрметті әріптестер. Асхат Айтимовтың объектілерді тану алгоритмі мен әдісін талдау және әзірлеу тақырыбындағы диссертациялық жұмыс бұл академик Әмірғалиев Еділхан Есіпханұлының жетекшілігімен негізгі нәтижелері алынған. Жағдайларға байланысты ары қарата жұмыс жалғастырылды және бірнеше қосымша нәтижелер осы диссертацияға қосылды. Мұнда зерттеудің негізгі маңыздылығы объектілерді тану мәселесінің қазіргі замандағы өзектілігі мен оның түрлі салаларда кеңінен қолданылуы болып табылады. Мұнда негізінен объектілерді тануға арналған алгоритм және тәсіл әзірленеді. Осы көрсетілген бағыттарда адам менен компьютердің арасындағы бірлесе отыратын өзара әрекеттестікті қамтамасыз ететін әртүрлі интерактивті жүйелер және технологиялардың қазіргі кезеңде қарқынды дамуына байланысты бұл жұмыс өте маңызды және өзекті болып табылады. Диссертациялық жұмыста негізінен үлкен екі деректер жиынтығына негізделген. Бұл бірінші деректер жиынтығы ORL және Hand-Reader деректер жиынтығы. Негізінен көптеген салаларда қолдану кезінде бұл деректердің шектеулілігі жұмыстың ары қарай дамуына өте қиындығын тигізеді. Сондықтан осы диссертациялық жұмыстың ішіндегі жаңашылдықтың бірі бұл шектелген деректер жиынтығында әртүрлі жақсы нәтижелер, тиімді нәтижелердің алынуы болып табылады. Диссертациялық жұмыста мұнда ең негізгі бір ерекшелігі және жаңашылдығы бұл біз машиналық оқыту мен компьютерлік көрудегі кәдімгі классикалық тәсілдерді үйлестіре отырып, ол атап айтқанда PCA, Modified Triplet Simulated Function және Projection әдістерін үйлестіре отырып, жаңа әдістің және алгоритмнің әзірленуі. Бұл PCA TP алгоритмі, бұл объектілерді тану жүйелерінің тиімділігін арттыруға біршама көмегін тигізіп отыр. Диссертациялық жұмыс өзі ағылшын тілінде дайындалған және диссертациялық жұмыстың басында осы сала бойынша жасалынған көптеген ғылыми нәтижелердің және әдеби шолуы өте кең түрінен берілген. Яғни осы саладағы барлық зерттеу тәсілдері және алгоритмдері зерделей отырып, талдай отырылып, кең жүйеде берілген. Мұнда зерттеудің нәтижелері бұл компьютерлік көру тәсілдеріне үлкен үлес қосатындығын тағы да айта кеткен жөн деп ойлаймыз. Жаңа мен айттым, бұл екі негізгі деректер жиынтығы пайдаланылған. Мұнда ORL жиынтығы кезінде PCA TP әдісін қолдану барысында өте жоғарғы дәлдік, атап айтқанда 99%-ға жуық эксперименттер кезінде осындай дәлдіктер алынды. Біз екі бейне үлгісімен қарастырған кезде 92,17% және үш бейнелік үлгіні қарастырған кезде 96,79% дәлдік нәтижелері бұл алынған. Енді зерттеу барысында бұл әртүрлі метрикалық бағалаулар қолданылған және эксперименттердің жүйелілігін зерттеу барысы бұл осы алынған нәтижелердің ғылыми қатаңдығын және дәлдігін көрсетеді. Егер және екінші деректер жиынтығы, Hand-Reader деректер жиынтығын қарастыру барысында мысалы бірнеше кәдімгі машиналық оқытудың бірнеше тәсілдері қолдана отырып, мысалы ең жақын көрші, KNN және кездейсоқ орман дейміз, РФ, сызықтық дискриминантты талдау және де тірек векторлар машиналары, шешім ағашы, детей және наивті байс классификаторлары қолданылып отырған. Бұл мәліметтердің алдын ала өңделінуі, сонымен бірге жасалынған эксперименттер 97% дәлдікті көрсетіп, және осындай пайызды көрсеткішті алуға мүмкіншілік беріп отыр. Бұл нәтижелердің көпшілігі уәкілетті орган тарапынан ұсынылатын ғылыми басылымдар тізімінде жарияланған. Осы хандридер деректер, шектелген деректер жиынтығында негізгі РФ және MSRC тәсілдерін пайдалану барысында қолданылған алгоритм бұл 97,5%-ға дейінгі дәлдікті көрсетіп отырды. Енді соңғы осы зерттеулерде, соңғы бірнеше жасалынған эксперименттерде тағы да осы ең жақын көрші және PCAP, тағы да PCATP алгоритмдері бір-бірімен салыстырыла отырып, қайсы алгоритмде негізгі жоғарғы дәлдіктің алынғандығы және қандай нәтижелер алынғандығы кестелі түрде көрсетілген. Жаңа презентацияда сіздер өздеріңіз көрдіңіздер. Бұл зерттеулердің көпшілігі осы зерттеу нәтижелері Scopus базасына енгізілген ғылыми басылымда жарық көрген. Енді Askhat Aitimov conducted over 40 scientific experiments using approximately 10 different algorithms and methods. The results of his research have been published in 9 scientific papers, 3 of which appeared in high-impact Q-ranked journals, and 2 of them were published in journals recommended by the state lists. Considering the above, Askhat Aitimov's dissertation fully meets all established requirements, deserves approval and recommendations for defense, and the Askhat is worthy of being awarded the degree of Doctor of Philosophy, PhD in 6D0700400 Computing Systems and Software, based on the public defense of his dissertation. And I asked my colleagues support this dissertation and support our colleagues, Askhat Aitimov, because his dissertation is very useful for many types of tasks. One of them, it's transportation tasks, when we have only limited limitation types of dates, and we analyzed and must decision making have only a limitation data.
Okay, thank you.
I asked all my colleagues support this dissertation and Askhat Aitimov's work. Yeah. Thank you very much for your attention. Thank you.
Briefly, translation of the Kazakh speech. So the study of Askhat Aitimov, the candidate for PhD degree, primarily focuses on developing algorithms and methods of feature recognition and object recognition. So we know that in these areas, various interactive systems have been created that facilitate interaction between humans and computers, allowing real-time execution of actions. The dissertation is primarily based on a dual director system. The first director system serves as the foundation, and the secondary, mainly applied in certain specific tasks, reveals significant challenges due to the limitations of the system. So a key feature and innovation, or we can say novelty of the dissertation, is that we integrate classical methods in computer vision with probabilistic approaches, in particular methods such as PCA, modified triple simulation function, and projection techniques. The development of these new methods and algorithms include the PCA type algorithm that allows for more accurate object recognition by capturing subtle differences in object positions. The highest accuracy in the experiments showed 96.19%, and in the hand reader and ERF algorithms even went up to 97.5% of accuracy. So generally, the work has been done, and we believe that this collection of the main data will broadly contribute to the improvement in different spheres and tasks, and we believe that this collection of the main data will broadly contribute to the general improvement in the sphere.
Thank you very much, colleague.
So we
Thank
have a
you.
translator
Thank you.
here, so
Yes,
if you
yeah.
can speak in any language.
Briefly of my speech, briefly of my review is translated with my colleagues. Thank you very much. Thank you.
So the next speech is from the Forensic Scientific Supervisor, Yuri Krak. Please, floor is yours. Можно на русском, если хотите. У нас есть переводчик.
Dear colleagues, I planning to speech on Russian, but if dissertation in English, I can read my review in English. Okay?
Yeah, you can do it in English, so it will be shorter, just a small conclusion. Yeah, okay.
Okay. Dear members of Dissertation Defense Council, dear Professor Sultanat Marghalieva, dear colleagues, dear friends, as external supervisor, it was a pleasure for me to work with Askhat Aitimov on your dissertation investigation. These problems some years ago were posed for Askhat by the great scientist, academic, professor, and my friend Adilkhan Marghaliyev. It was very sad that he passed away. I should note that Askhat Aitimov dissertation on topic analysis and development of algorithms and method for object recognition is devoted to the most important and very relevant topic in the field of computer vision and machine learning. Particularly important in this research is the development of algorithms as method for gesture recognition and demonstrate superior performance in the context of limited data sets. The result of the research is the development of PCA-TP algorithm with combined principal component analysis, triplet similarity function, and projection. Additionally, the study includes the application of two datasets, the hand reader dataset for gesture recognition and or oral face dataset, and report and impressive accuracy for the PCA-TP algorithm. Thus, the following issue can be noted in terms of its novelty, methodology, result, and overall quality. Incorporation hand gesture recognition into object recognition research expands the scope and applicability of the study. This allows for deeper understanding of human-computer interaction, improves accessibility, and improves the reliability of object recognition system, especially when data is limited. Additionally, this combination opens the door to a wide range of practical application where hand gesture recognition and interpretation play a crucial role in improving user experience and system functionality. Askhat Aitimov dissertation demonstrates significant novelty by solving the difficult problem of object recognition in a limited data set. Integration of PCA triple similarity function and projection into the PCA-TP algorithm represent an innovation approach to improve object recognition performance. This combination of established method has potential to make significant contribution to the field. Additionally, the use of hand rider dataset and face dataset add value to the study to improve an valuable resource for future research in this era. I know the dissertation is written in English at a good scientific and technical level. The results presented in the dissertation are very accuracy with the PCI-TP algorithm is a significant achievement, especially in the context of a limited data set. The use of various evaluation metrics and tests to evaluate the performance of an algorithm demonstrates a rigorous and systematic approach to experimentation. To summarize this work, a commendable and valuable addition to the field of object recognition and constraint problem solving on dataset, with the potential to impact various applications in computer vision. Considering above, I believe that Askhat Aitimov's dissertation, Analysis and Development of Algorithm and Method for Object Recognition, as completed qualification work, meet all requirements for the PhD dissertation in the specialty computer system and software, and the author Aitimov Askhat. They served to be awarded the degree of Doctor of Philosophy in this specialty on the basis of public defense. Thank you very much, Rahmet.
Thank you very much. Thank you, Professor. Okay, then we now ask our official reviewers to make a speech. First, I would invite Dr. Ismailov Nurjigit to talk about his review.
Қайырлы күн, құрметті әріптестер және магистранттар, докторанттар, қонақтар. Жалпы ресми рецензенттің жазбаша пікірі 6D070400 есептеу техникасы және бағдарламалық қамтамасыз ету мамандығы бойынша философия докторы ғылыми дәрежесін алу үшін Айтимов Асхаттың диссертациялық жұмысына пікір. Тақырыбы объектілерді таңдау алгоритмі мен әдісін талдау және әзірлеу. Енді мына жерде өте көп 15 пунктқа тоқталу керек екен. Мен енді олардың барлығын толыққанды айтып, уақыт созбай қысқаша айтып өтсем.
Рахмет.
Аударама или қалай?
Okay. Yeah, you can continue. He will do the conclusion in the end.
Аяқтай беріңіз соңына дейін, сосын аударамыз.
Толық бітірем ба? Жақсы. Бірінші пункт бойынша диссертация тақырыбының бекіту күніне ғылымның даму бағыттарына байланысты жаңа мемлекеттік бағдарламаларға сәйкес болуына. Жалпы бұл Айтимов Асхаттың диссертациялық жұмысы әдістемелік тұрғыдан дәйекті және практикалық маңызды жоғары болып табылады. Дегенмен де бұл Қазақстан Республикасының ғылым мен технологиясының басым дамуына бағыттарына, атап айтқанда жасанды интеллект, компьютерлік көру және цифрлық технологиялар саласында сәйкес келетіндігін айтып өткім келеді. Ғылым үшін маңыздылығы диссертациялық ғылымға елеулі үлес қоса алады және оның маңыздылығы нақты түрде біз жаңа айтып кеткендей бұл зерттеу шектеулі деректер жайында объектілерді танудың ғылыми негіздері кеңейтіп жаңағы жұмыс ғылымға елеулі үлесін қоса алады деп санаймын. Мұндай жаңағы көрсетілген TP алгоритмі ұсынылады. Бұл объектілерін мұндай объектілерді метрикалық оқыту және проекцияның тәсілдерін өзара байланыстыратын тереңірек түсінуге мүмкіндік береді деп санаймын. Бұл өз кезегінде деректер жеткіліксіз болған жағдайда тану дәлдігін арттыруға ықпал етеді. Алынған нәтижелер компьютерлік көру саласының теориялық және әдістемелік дамуына елеулі үлес қосып, жасанды интеллект саласындағы тиімді тәсілдердің одан әрі жетілдіруіне негіз бола алады. Үшінші пункт бойынша өзі жазу принципі, яғни осы Айтимов Асхаттың диссертациялық жұмысы жоғары деңгейде жазылған. Дегенмен де автор өзінің теориялық негіздерді терең түсініп, материалдарды, әдебиеттік шолуларды толығымен аша алған. Дегенмен де бұл берілген әрбір мәтіндік академиялық талаптарға сай жазылып, барлық бөлімдерге ғылыми дәлдік пен терминологиялық бірізділік сақталған деп санаймын. Дегенмен эксперименттер, талдаулар және нәтижелерді түсіндіру толықтай автордың өз еңбегімен орындалғандығы бұл оның жеке үлесіне және зерттеу нәтижелеріне толық авторлығын растайды. Төртінші пункт бойынша ішкі бірлік принциптеріне байланысты диссертация өзектілігінің негіздемесі толық негізделген. Диссертациялық жұмыстың өзектілігі толықтай айтылды, жазылған. Зерттеу компьютерлік көру саласындағы маңызды мәселелердің бірі екендігіне көз жеткізуге болады және әрі тиімді объектілерді тану алгоритмдерін әзірлеуге бағытталған. Оларындағы қазіргі ғылыми бағыттар мен алгоритмдерді тұрақтылығын негізгі зерттеу басымдықтары болып табылады. Диссертацияның мазмұны диссертация тақырыбына айқындайды. Диссертацияның мазмұны әрбір бөлім жұмыстарының негізгі мақсатында тікелей сәйкес келетіндігі, материал біздің және қисынды құрамда ұсынылған бұл жұмыстың ішкі үйлесімділігін және мақсатқа бағытталғандығын қамтамасыз ете алады. Диссертациялық жұмыстың мақсаттары мен міндеттері оның тақырыбына толық сәйкес келеді. Зерттеудің негізгі мақсаты жаңағы Орел сияқты шектеулі деректер жиынтықтары, PSA типі алгоритмін жобалау, сондай-ақ оны классикалық және заманауи тану әдістерімен салыстырмалы бағалау қамтылған. Диссертацияның барлық бөлімдері мен ережелері логикалық байланысқандығымен айтқым келеді, және де диссертацияның құрылымы толықтай өзара теориялық негіздер мен эксперимент дәлелдерге дейінгі айқын логикалық бірізділікті сақтайды. Кіріспе бөлімінде зерттеу мәселелері айқындалып, шектеулі деректер жағдайындағы объектілерді танудың өзектілігі негізделген. Сондай-ақ зерттеу мақсаттары мен міндеттері тұжырымдалған. Әдеби шолу бөлімінде бұрынғы зерттеулер жүйелер түрінде бұрынғы зерттеліп кеткен ғылымда жұмыстармен өзінің салыстыру арқылы өзінің жұмысын ажырата алған. Автор ұсынған жаңа шешімдер жаңағы объектілерді танудың қолданыстағы тәсілдері, жасанды интеллектке байланған SN, RS және де осы классикалық алгоритмдермен қатар трансфер learning және генеративті қарсылас әсілдер ANX сияқты заманауи терең оқыту әдістері қарастырған. Бесінші, ғылыми жаңашылдық принциптері. Диссертациялық жұмыс шектеулі деректер жағдайында объектілерді тану саласында толығымен жаңа ғылыми нәтижелер ұсынған. Автор берілген тұтас құрылымды қалыптастырған және де беріліп отқан алгоритмдерді қоса алғанда әзірлеген. Ұсынылған әдіс басты компоненттерді талдау, бейімдегі шекті бар модификацияланған трафик тұтастық функциясы және проекцияға негізделген классификация кезеңдерін біріктіріп танудың біртұтас тәсілін құрайды. Диссертацияның қорытындылары жаңа ма? Толығымен жаңа деп айтуға болады. Дегенмен зерттеу барысында жаңағы проценттік нәтижелермен көрсететін болсақ, алынған нәтижелер ұсынылған тәсілдің шектеулі деректер жағдайында сенімділігін расталады. Ең аз үлгілермен оқыту кезінде 92%-тен жоғары, ал қосымша деректер пайдаланғанда 96%-дан асатын тану дәлдігіне қол жеткізеді. Және де техникалық, технологиялық, экономикалық және басқару шешімдері жаңа және негізделген бе, толығымен жаңа деп атауға болады. Диссертациялық жұмысты ұсынылған техникалық шешімдер бұл бізге Орел және трейдер деректер жиынтықтарын жүргізілген эксперименттер әртүрлі оқыту конфигурациялар мен шешімдердің тұрақтылығы мен тиімділігін растады. Әдістемелік негізділік пен тәжірибелік нәтижелердің үйлесі ұсынылған тәсілдің ғылыми және практикалық тұрғыдан кеңінен дәлелденгендігін атап өтуге болады. 6-шы пункт бойынша негізгі қорытындылардың негізділігі. Бұл жерде эксперименттер түрлі деректер шектеулер мен оқыту үлестер жағдайында орнатылып, алынған нәтижелердің сенімділігін, тұрақтылығын растайды. Қорытындылар әрбір бөлімде қойылған мақсаттар мен алынған нәтижелер қойылған толық сәйкес келеді. Және де бұл жерде ғылыми дәлдігі мен сенімділігін қамтамасыз ете алады. Қорғауға шығарылған негізгі ережелер. Әрбір ереже бойынша келесі сұрақтарға жеке жауап беру қажет дейді. Жалпы ереже дәлелденеді ме? Дәлелденеді. Және де бұл жерде тривиалды ма дейді. Жоқ, бұл
ана жақта қысқаша айтсаңыз да болады. Қатты тереңіз.
Жаңа ма дейді, иә, бұл қолдану деңгейі кең, мақалада дәлелденген ба, иә, көрсеткен эксперименттердің нәтижелері барлық мақалалармен толығымен расталады.
Қорытынды айтсаңыз.
Енді соңында осы қорытындылай келе, жалпы диссертант барлық талаптарға сай жұмыс жасаған, дегенмен де осындай техникалық қателіктер бар. Бұл диссертацияның деңгейін түсірмейді. Болашақта ғылыми жобаларда өзінің деңгейін осы диссертация жалғасы ретінде көптеген жаңағы машиналық оқытуларды өз деңгейінде, жоғары деңгейде алып шығуына үлес қоса алады. Айтимов Асхаттың болашақта сол ғылым саласында үлесін қосып, осы жаңа жасалып жатқан ескертпелердің барлығы болашақта түзеліп, ғылым саласында үлес қосылатынына көз жеткізуге болады. Сонымен қатар диссертациялық жұмыстың академиялық жазу сапасы орта деңгейде, PhD дәрежесіне қойылған талаптар, жалпы талаптарға сәйкес келеді. Мәтін ғылыми және біздің стильде жазылған, қолданылған. Диссертацияның құрылымы, кіріспе, әдеби шолу, әдістеме, эксперименттік бөлім және қорытынды материалды түсінікті әрі дәйекті түрде ұсынуға мүмкіндік береді. Докторант мақалалар, яғни жалпы талаптарға сай мақалалар Scopus базасына енетін мақалалармен толықтырады. Және де біздің Айтимов Асхаттың 6D07-04-00 есептеу техникасы бағдарламалық қамтамасыз ету мамандығы бойынша философия докторы PhD дәрежесін беруге ұсынамын.
Жақсы, рахмет.
Беруші Смайлов Нұржігіт Құралбайевич.
Рахмет сізге, профессорымыз. Thank you very much. So maybe very short translation.
Yes, briefly they review the work on feature recognition algorithms studied by PhD candidate Askhat Aitimov has been done, and I would like to mention several issues here. First one, the methodology and practicality of the work fully suits, including such spheres as machine learning and AI. The significance of the work is that the limited data set based on such algorithms as TPA is very relevant nowadays in recognition sphere. The principle of academic integrity has been fully applied with the full-scale literature review that was fully covered and experiments in practical part that were explained in details. The relevance of the work is high level since the study of feature recognition in computer science sphere is highly ethical and relevant nowadays. The contents of the work fully match the standards, and the objective of the work is to study the limited data sets in such in the usage of such algorithms as PCA or TPA. We can say that the theory fully complies with the practicality of the work. We can see the vivid parts of the work, starting from introduction and literature review and practical part of the work. I would like to focus on literature review separately. That it's obvious that all previous studies in this field are analyzed essentially, and in practicality part, in the practical part, the classical algorithms are studied hand in hand with the modern algorithms, and we could say that the experiments that were conducted by the researcher shows amazing results with accuracy, in most of them with the accuracy more than 90%. So the conclusion of the work is logical and fully aligns with the results. So we could say that the dissertation work has met the standards, though there are some technical slips that can easily be corrected by the candidate. So I'm fully confident that the work will contribute to the future advancements of this sphere. I would also mention that articles and publications, including Scopus publications, are included in the candidate's works, which is also honorable. Thank you very much.
Okay, thank you. So we have a second review. So please, floor is yours, Dana Turlukhojaeva. You can briefly explain about your review and yeah, thanks.
Thank you. Let's start. The dissertation presented by efficient and gesture recognition under limited data conditions. The topic is highly relevant as achieving robust recognition performance with small datasets remains a presenting challenge in computer vision, especially for embedded and resource-constrained systems. The work is clearly structured with well-defined objectives and logically formulated tasks. The proposed integration of PCA modified algorithm represents a scientifically significant contribution. The introduction of the modified tripled loss function, combining cosine similarity, adaptive margin adjustment, and projection consistency adds notable originality and expands methodological approaches to machine learning methods. Key strengths of the study include the solid theoretical foundation, the unification of dimensionality reduction and metric learning techniques, and then demonstrably highly performance and limited data sets. Minor suggestions concern expanding comparison with the existing lightweight models, which could further strengthen the empirical analysis. Overall, the dissertation is innovative, theoretically substantiated, and practically valuable. It contributes to the development of interpretability and efficient recognition systems suitable for applications with restricted computational resources and limited data availability. The work is recommended for defense in the specialty 60070400 computer engineering software.
Yeah. Thank you, Professor. Thank you very much. Candidate, maybe have some answers related to the concerns.
Okay. All comments are analyzed, and in future I will do all the recommendation because it's related to in working in real data. It was also like a, how to say, advice. So thank you for your advice.
Okay, thank you. So we finish with this part. Then now we would like to move to some next stage, the discussion of the dissertation of this council meeting. So who would like to speak? Maybe some short insights on the results of this discussions of the presentation and so on. Anyone would like to say some words? From the committee members? Urrogas Hanım? Okay, I will begin maybe. So we had very thorough discussion of his topic. We understood that the topic is related to a very limited, specific case of research where you have a specific task with a hand gesture and the face recognition, and it also focused on the improving the algorithm, which are state of the arts, so that it would be better and more suitable. As I understood, it's also used in some specific environments. It's very fast and lightweight. It can be applied in many areas because it's easy to run on simple environments. So in my opinion, it's a very good dissertation topic, and also some results are achieved. So others, maybe some brief words? No? Okay, then that's enough. We move to the next stage. We need to, dear council members, according to the regulation, we now proceed to the secret voting procedure. To conduct this procedure, we need to elect the counting commission. Are there any proposals? So since most of us are online, so I propose Dana Utibayeva for the chief of the counting members, and others can be.
I think we offer the Dospayev Shandos and Aygirim Yerimbetova.
Okay, so Aygirim Yerimbetova and Dospayev Shandos, if you are not against, we can include you in the counting commission. Okay. and after a couple minutes. Okay, if then we approve the commission members. Yeah, okay, commission members approved. And now we're moving to the voting, and now we have a break. So now we can go to the break, and after a couple minutes, we will call you. Oops. Please come in. Our voting committee have concluded their work, and now I give the word for the head of the committee, Dana Otibaeva, please.
Thank you. So on the basis of open voting, the commission was elected, and the commission was elected to count votes during the secret voting on the dissertation of Askhat Aitimov on the topic analysis and development of algorithm and method for object recognition in the specialty 6D070400 computing systems and software. So the secret voting was conducted electronically. Total electronic ballots submitted 8, invalid ballots 0. So voting results regarding the award of PhD degree to Askhat Aitimov in their specialty 6D070400 award the degree of Doctor of Philosophy or Doctor of Science in the relevant field 6 votes. Sent to dissertation for revision 2 votes. Sent to the dissertation for the redefense 0, refuse 0 votes. So this is the result of.
Okay, thank you very much. Now I think that we need to vote for the approving of this results, the protocol. No one against? Okay, everyone for this. Then, yeah, committee members. Yeah. So we as a committee members, we're approving the protocol, and then it means that if we're all in favor for this commission protocol, then the Dissertation Council for Educational Programs 8D06102 Computer Science and in the specialty 6D070400 Computer Systems and Software at the University based on the public defense of the dissertation of Askhat Aitimov on the topic analysis and development of algorithms and methods of object recognition has decided to petition the committee for the awarding of the degree of Doctor of Philosophy PhD for him. Okay, thank you. The candidate is given the floor for the final remarks.
Okay, thank you for everybody. So especially for my supervisors, external supervisors who support me in this way. Also committees, ESO committees who helped also supported to this PhD defense, and for all who attending to the PhD. Thank you.
Thank you very much. So in this case, we can conclude our dissertation council. Thank you very much. Thank you all for the presence. Thank you, professors, for coming today and attending the dissertation council. Thank you for your work. Goodbye.
Okay.
My congratulations.
Okay, thank you.
Oh.